May 2018, Paper 1, Time Zone 2, Standard Level. This question for IB students. Question 19. A cell with negligible internal resistance is connected as shown. The ammeter and the voltmeter are both ideal. What changes occur in the ammeter reading and in the voltmeter reading when the resistance of the variable resistor is increased? Shown here in the diagram, the variable resistor has a sliding contact. So the resistance of the variable resistor increases. It means that the more energy consumed across the variable resistor, so it means that the voltage across the variable resistor increases as well. So the reading of the voltmeter increases because of what? More energy consumed through the variable resistor, according to the formula, which is V equals W over Q. Okay, for the point of the ammeter reading, we see that total resistance increases. The reason is because of the increase in the variable resistance, which is already connected with a fixed resistor. So the total or the equivalent resistance for both series connection increases. And according to Ohm's law, V equal I times R, the voltage across the whole electric circuit from the main power supply from the dry cell is already constant, and the R increases, so the I must be decreased to balance the mathematical equation. This one from the point of math or mathematically, but in physics, because the total resistance increases, which it means opposes too much electrons from not moving, so trying to decrease the or lowering the number of electrons coming from the main power supply to decrease the rate of the charges passing through the wire, which it means finally decreasing the electric current. So the reading of the ammeter decreases. The correct answer finally is C. Change in ammeter reading decreases and change in voltmeter reading increases.